Hey everybody, let's talk about correlation and residuals. So what these two terms are going to do is they're going to help us figure out how good is our line of best fit. How is it? Is it a good fit? Do we choose a good line? It's going to tell us a little bit more information than you just plain see on the line of best fit. So correlation, what it's going to do, it tells us how strong and the direction of our line of best fit. And it's often represented by this letter R. So it's going to tell us how strong and the direction of our line of best fit. R is going to be a number given to us, and it's usually a decimal that's going to be from -1 to +1. Okay, so we're looking at all decimals in between here. So all the negative decimals over here, all the positive decimals over here. So it's going to tell us two things. It's going to tell us how strong the fit is and the direction. So if this number R is between 0 and 1, it's any of these positive numbers, what that means is we have some sort of scatter plot that is heading in a positive direction. So if the number is positive, we know our line is heading in a positive direction. It has a positive correlation. Where if R, our decimal, is negative, then we know our scatter plot is set up to trend downwards and have a negative slope, so it's coming down. So it's going to tell us the direction. If the number is positive, we know the direction is positive. If we know the number is negative for R, then we know the direction is negative. Okay, so that's how we know what direction we're going. The other thing it's going to tell you is how strong our line of best fit is. And here's how it's going to work. It can be a little bit tricky. If our number is really, really close to 1, it's going to be a strong fit. If it's really, really close to -1, it is also going to be a strong fit. So the closer we are towards the ones, 1 or -1, the stronger we are. If we're close to this number 0, that means it is a weak fit. So what does that even look like? So let's say we have a scatter plot. We have a line of best fit here that's positive. A strong fit means all my points from our scatter plot are going to be very, very, very close and snug to that line. That they're all going to head in a positive direction. It's real obvious what the trend is. They're going to be really, really tight around that line of best fit. And you would expect the same thing for down here, except the only difference is instead of heading in a positive direction, they're going to be clustered really close around the line, but going in a negative direction. Here's what it means to be weak. You're going to have a scatter plot and your line of best fit, but the only thing is we don't want the points nice and clustered really, really close. Instead, they're going to be very, very spread out away from the line. So it's a little bit more of a mess that, it might not be super obvious what the trend is, but things are a lot more spread out. So when you think strong, we're going to be nice and close. When you think weak, we're pretty spread out. So if you're close to the ones, 1 or -1, we're strong, have a strong fit. If you're close to 0, we have a weak correlation there. The other way we could talk about the spread of these points around our line of best fit is we have this last vocab word, a residual. What that is, it's the vertical distance from a point in the scatter plot to our line. So what I have here is I just made a pretty basic scatter plot, a line of best fit. What a residual is, it's the vertical distance. So vertical being like this, the vertical distance from a point to my line of best fit. But here's the catch. The residual, if the point is above the line, it's going to be positive. If it's below the line, it's going to be negative. So let me zoom in here a little bit so you can get a better look. So if it's above it, it's going to be a positive residual. If it's below the line, it's going to be negative. So if I pick, say, this point right here, this is from my scatter plot. Here's my line of best fit. Again, the residual is the measure of this vertical distance right here. So that vertical line right there. And we could just count it here. So this residual, we have 1, 2, 3, 4. For this point, the residual will be 4. And since it's above it, it's going to be positive. I could do this for another point. How about this guy over here, this point? Again, it's the vertical distance. So it's this distance right here, a vertical line. And all you're going to do is just count the distance there. So 1, 2, 3. But since we're below, the residual is going to be -3. So points above it, you count the distance, that's positive. Points below it, you count the distance, that's negative. One other thing I want to show you is what about this point right here? It's already on my line of best fit. So if you're trying to count the distance, well, there is no distance there because it's already on top of my line. That residual would be 0 because I didn't count anything. So positive residuals, negative residuals, residuals of 0. And that's one other way we could talk about how spread out my data is around a line of best fit. So correlation and residuals are two ways we can kind of describe how well does our line fit our scatter plot.